All right, guys. This is just kind of like round one of review for solving equations. So remember, exponential and log equations are called transcendental equations because we're not using algebraic operations to solve here. Make sure that if you can match bases, that you do that. So your answers need to be in simplest form. On number one, I can rewrite both of these bases to be base 2. And if I do like log base 1/2 of both sides, your answer wouldn't be in simplest form. So you would not get full credit on the test if the answer is not in the simplest form if you could have matched bases. Okay, so I rewrote 1/2 to 2 to the negative 1. I rewrote 8 to be 2 to the third. And because we're doing power to a power, we can multiply these exponents together. So it's 2 to the negative 3x minus 2 equals 2 to the 15 minus 12x. And because these are the same bases, if this equation is equal, if this equation is true, then the exponents must be equal to each other. And it's okay with me if you skip this step here where you rewrite so that it's base 2. If you jump right from here to here, that's fine. Okay, otherwise we need to solve this. So I'm going to add 12x over here to get 9x. I'm going to add 2 to the other side to get 17. X equals 17 divided by 9. We should only have to check for extraneous solutions if we're solving a log equation. So remember, you can't log a negative value or 0. So keep that in mind as you're solving. Okay, number 2 is a log equation, so I want to isolate the ln. So I'm going to subtract 2, which makes this equal to 10, and then I'll divide by 3. So it's natural log. Change my colors here so that the work doesn't run together. Okay, so it's natural log of 2x minus 7 equals 10 divided by 3. So that was just I subtracted 2 divided by 3. And then to get rid of the natural log, you base e both sides. So if you do that, the base e cancels out the natural log, and you're left with 2x minus 7 equals e to the 10 thirds. We're not using a calculator, so just leave it like this. And then solve for x. So now it's a 2-step equation. So add 7 and then divide by 2. So you're adding 7 first, and then divide the entire thing by 2. So that's your final answer. Number 3 is an exponential equation, and it's a trinomial. It's one that we can factor. So remember, we begin by splitting e to the 2x into e to the x and e to the x. And you want the numbers that multiply to 56 that add up to 1. Well, add or subtract, I should say, to 1. So factors of 56, 8 times 7 is 56. So if I make it plus 8 and minus 7, that's going to add up to the plus 1 e to the x that I need in the middle. So then solving this, it would be e to the x equals negative 8 or e to the x equals positive 7. Now remember, for this one, e to the x will never be negative anything. Or if you go to natural log both sides, you get natural log of a negative. So that's no solution from that part. From this part, e to the x can equal 7. So we would natural log both sides. Natural log e to the x just gives us x equals natural log 7. And again, if you just go from here to here, that is perfectly fine with me. You can skip this step. I'm just reminding you what's happening there. Okay, now we just did a factoring problem, right? Number 4 is still just a factoring problem. And for some reason, when the base number is not e, when it's like a number that's not a letter, it confuses people. So we're going to factor this the same way. So how did we split up e to the 2x? Made it e to the x and e to the x. So how are we going to split up 5 to the 2x? We're going to make it 5 to the x and 5 to the x. And it's not that we want the factors of 12 that give us 5. Remember, it's what's in front of this. This is negative 1 times 5 to the x. So we want the factors of 12 that add or subtract to give us negative 1. So that's going to be minus 4 and plus 3. right? Because negative 4 times positive 3 is negative 12. Negative 4 plus 3 is negative 1. The base number is not getting multiplied in. It's not like it's 5 times 3 and 5 times 4. Okay, so then this would be 5 to the x equals 4, or 5 to the x equals negative 3. Just like we did before, 5 to the x can't equal negative anything because this is a positive base number. You can't raise it to an exponent and make it all of a sudden be negative, so there's no solution from here. From this one, you could log base 5 both sides. This is how we're doing it in our notes. You can log base 5 both sides so that you get x equals log base 5 of 4. Or if you prefer to natural log both sides, you could say, if you natural log both sides, it would be like x ln of 5 equals ln of 4, natural log of 4 over natural log of 5. Remember, these are equivalent because you get, this is just the change of base formula at work, right? Log base 5 of 4 is equal to natural log of 4 over natural log of 5. That's because you could either log base 5 both sides or natural log both sides and use your exponent rules. I like to just match the base. It's a bit faster. Okay, for this one, this is back to a log equation. There are a bunch of logs over here, so we need to condense this thing first. So let's condense all of these logs. So they're all log base 2. And then how do we do the condensing? If you're adding logs together, you multiply their results. So I need to multiply x minus 6 times x minus 4. So that's going to be x squared minus 10x plus 24. And then any log that gets subtracted becomes something that you're dividing by. So that whole thing is divided by x, still just equal to 2. All right, so now it's a single log equation. So how do we get rid of a log base 2? We base 2 both sides. Log base 2 cancels out, so you get x squared minus 10x plus 24 all over x equals, what's 2 squared? 4. How do I solve this equation? Well, I always want to get my variable out of the denominator, so I'm going to multiply it over to this side. So x squared minus 10x plus 24 now equals 4 times x. This is a quadratic equation that we need to get equal to 0, so I'm going to bring my work up here. So if I subtract 4x, I get x squared minus 14x plus 24 equals 0. And I need to factor this. So what are the factors that multiply to 24 and add or subtract to 14? So for 24, it's we use 6 and 4 a lot, but that's not going to add to 14. So don't forget about 12 and 2, and I want them to be negative 14. So if they're both negative, they'll add to negative 14. So then I get x equals 12 and x equals 2. Now remember, this is a log equation, so I need to double check my answers. Can I plug 12 and 2 back into the original equation and get the log of a positive value? So 12 is fine, right? Because 12 minus 6 is positive, 12 minus 4 is positive, and 12 is positive. But if you plug in 2, that's not going to work because 2 minus 6 is negative. 2 minus 4 is negative. 2 works here, but it doesn't work for the first two. So 2 is extraneous because it causes you to log a negative value back in the original equation. 12 is the only solution to that one. All right, for number 6, we have logs on both sides. So let's go ahead and condense here. So this is the log of 5 times x minus 2, 5x minus 10. Now, I could say equals log of 100. I could solve this right now. Like, these are both logs. I could just say 5x minus 10 equals 100. This is that one-to-one property. So add 10 to the other side. Divide by 5. So let's see. 5 goes into 11 twice with 1 left over, and then 5 goes into 10 twice. So 22. Or you could have also done this. Log of 100 is something we can evaluate. That's equal to 2. So you could have still condensed this side. The log of 5x minus 10 equals 2. And then if you do that, you're going to base 10 both sides. So see how you get to the same place. you still get to solving this equation. So 2 ways to show the work for that one. Now for number 7, I don't want to log base 3 both sides or log base 4 both sides, because that makes it really hard to isolate the x's and solve for x. You can try it if you want to. It's kind of tricky. So instead, I would just natural log both sides or common log both sides. I tend to natural log. So if I natural log both sides, that does not cancel out either of these two base numbers. So when the log does not cancel the base, instead what you do is use the expanding rule that says an exponent inside of a logarithm can be rewritten as a multiplication problem. So we can take in parentheses 3x minus 5 multiplied by natural log of 3 and the quantity 2x plus 1 multiplied by natural log of 4. And there are x's on both sides of this equation, so to be able to isolate the x's, we need to distribute the natural log of 3 and the natural log of 4 through their parentheses. So 3x natural log of 3 minus 5 natural log of 3 equals 2x natural log of 4 plus natural log of 4. Anything with an x needs to get moved to the same side. It doesn't matter which side you move to. I'm going to move to the left. So 3x natural log of 3, and then that means I have to subtract 2x natural log of 4. Anything without an x is going to get moved to the other side. So I already have natural log of 4 over here. I would need to add 5 natural log of 3 to the right side. The purpose of getting your x's on the same side is so that you can factor an x out. And what would you be left with? You'd be left with 3 natural log 3 minus 2 natural log 4 equals the rest of this stuff. There's nothing to do on the right side. And factoring the x out means that it's x times this parentheses, so we can divide by the entire parentheses to send it over to the other side. So it's natural log of 4 plus 5 natural log of 3 over 3 natural log of 3 minus 2 natural log of 4. Now, I'm not going to, but you could practice your condensing skills by moving exponents and condensing with multiplication and division and just seeing what you have to work with. But I'm going to leave that alone. Okay, for number 8, I'm back to an exponential equation, and it's base e. So before I can natural log both sides, I have to make sure that I get rid of anything that's outside of the e. So I need to isolate the e term. So divide by 2. It's e to the 2/3 times x minus 6 is now equal to 12. So now I can natural log both sides. The natural log and the base e cancel out. So you have 2/3 x minus 6 is just equal to natural log of 12. To solve for x, you would add 6. Do this in 2 steps because fractions tend to mix us up. So 2/3 x is now equal to natural log of 12 plus 6, which is not natural log of 18. Remember, the plus 6 is outside of the log function. And then if you're multiplying by 2/3, how do you get rid of that? You multiply by 3 halves. So either use the parentheses or distribute. It could be 3 halves, natural log of 12 plus 9 if you do 3 halves times 6. But I would just leave it like this. For number 9. Now, this is not quite the one-to-one property as it is right now because it's not log equals log. It's 2 times log equals log. So you need to fix this first. How do I get rid of the 2 that's in front? I make it an exponent. So I'm condensing. So this is really the log of x squared equals the log of 25. Now this is the one-to-one property because it's log equals log. So you can just say x squared has to equal 25. And we're used to getting plus or minus 5 when you square root both sides. But remember, you can't log a negative. So negative 5 is out because you can't do 2 log a negative 5. That's no good. So it's only x equals 5 for the solution. What about number 10? This is an exponential, but the e is in the denominator. And you can't just rewrite this because there's a 1 plus e to the 2x. You can't just make this like e to the negative 2x and move it up. So instead, take this denominator and multiply it over to the side. So 20 times 1 plus e to the 2x is equal to 50. And the reason I didn't distribute the 20 through is because I would just like to turn around and divide by 20. We're trying to isolate the e to the 2x. So the first step was to get it out of the denominator. The next step is to begin isolating. So 1 plus e to the 2x is now just equal to 5 over 2. Subtract 1 from that. Now go ahead and actually subtract 1. Don't just write 5 over 2 minus 1. So 5 over 2 minus 2 over 2 is 3 over 2. Then I can natural log both sides. The natural log of e to the 2x is 2x. And that equals natural log of 3 over 2. And then you divide by 2. So the natural log of 3 over 2 divided by 2 is my solution. Number 11 is an exponential. When they're numbers, I always see if I can match the bases. So 27 and 3 can both be base 3, right? So 27 is 3 to the third. And then it's to the x squared. And instead of a square root, this could be 3 to the 4x, and you're raising it to the 1/2 power. So let's clean that up first. So it's 3 to the 3x squared equals 3 to the 2x. Power to a power, you multiply your exponents. And because they're both base 3, I can drop the base 3's and just say, okay, 3x squared should equal 2x. Now remember, you don't want to divide by x here because you'll lose a solution. You want to instead say, this is quadratic, so I should get it equal to 0. And factor, all you can do is factor an x out. But that gives you two solutions. It gives you x equals 0 and x equals add 2 divide by 3, 2/3. And this was an exponential equation, so we can get 0. It's not like a log where we can't plug 0 in. All right, so that's our final answer. We have two solutions. Number 12 is just like number 7. I just gave you different base numbers, different exponents. So we can't log base 7 or log base 3. That'll complicate the problem. So instead, we're going to natural log both sides. And you kind of, for these problems, you're really going through the exact same steps every time. The only thing I can do is change the numbers. So I'm going to natural log both sides. I'm going to expand by bringing the exponents down into a multiplication problem with parentheses. That's important. So the quantity 2x plus 1 times natural log 7 equals the quantity x plus 2 times natural log 3. Next thing is to get rid of parentheses, distribute the natural logs through. So 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. Next thing is get your x's together. I'm going to move them to the left. 2x natural log 7 minus x natural log 3. Move non-x's to the right. So I already have 2 ln 3 over here. I need to subtract ln 7. Factor out an x, which leaves you with 2 ln 7 minus ln 3. Nothing happened on the right side, so I'm just writing it down. And finally, divide by your parentheses. So it's going to be 2 natural log 3 minus natural log 7 over 2 natural log 7 minus natural log 3. All right. Number 13 is just like number 4 and number 3. It's a factoring problem. It's a trinomial. Okay? So this is supposed to say 4 to the x, by the way, in the middle. So break 4 to the 2x into 4 to the x and 4 to the x. You want the factors of negative 35 that add or subtract to give you 2. So the 4 is not involved here. The 4 is just the base number. So 7 and 5 have a difference of 2. So if I do plus 7 and minus 5, that's going to give me the positive 2 in the middle when I add them together. So this means that 4 to the x could equal negative 7, or 4 to the x could equal 5. Remember, in these last two problems, anytime the base number was equal to a negative, we threw that out because you won't be able to log -7. I can solve this equation, so I'm going to log base 4 both sides, or you could natural log both sides if you want. Log base 4 just gets this right down to x equals log base 4 of 5. If you natural log both sides, then it would be x equals natural log of 5 over natural log of 4, if you do that math correctly. If you natural log and bring the x down and divide. Number 14 is not a factoring problem because I don't see a trinomial setup, but it is a base 10 problem, and we need to isolate this exponential term here. So subtract 3 to begin with. So this is 2 times 10 to the 5 minus 2x is now equal to 13. And then divide by 2. So 10 to the 5 minus 2x is now equal to 13 divided by 2. We're going to common log both sides because a common log will cancel out a base 10. So it's 5 minus 2x equals the log of 13 over 2. Then you need to subtract 5. So log of 13 over 2 minus 5. You're not subtracting 13 over 2 minus 5 and getting 3 over 2. We're not doing that. And then divide by a negative. By a negative 2. If you moved your x term to the right side, it could also be 5 minus log of 13 over 2 divided by positive 2. So that would work as well. For any of these, if you have the exact opposite answer for any of the log equations, that's just because we moved our x's to a different side, so that's okay. All right, what about inequalities? We did these on a homework assignment before break, so let's remember how to do this. Now, if it's exponential, like 15 and 18, you should be factoring and then using a number line and testing sections. If it's a log inequality, we have not done a log inequality yet. I'm only going to give you basic logs. So the best thing to do is just think about the graph, which we need to graph these for our test anyway. So good practice on that. Let's start with the exponential. So take a look at this. And there should be, hold on, let me see if I fixed this for my key. Yeah, there should be an e to the x on number 15. I'm not sure if I fixed that for your worksheet or not, but it should say minus 18 e to the x. Because the first thing to do is factor out an e to the x. So that's x squared plus 3x minus 18. Less than or equal to 0. If I didn't have an e to the x on there, this would be a much harder problem that we would maybe use a calculator for. Okay, then we need to factor this a bit more. So e to the x is out there. This would be x plus 6, x minus 3, less than or equal to 0. And remember, you're trying to set these equal to 0 to get your critical numbers. Is e to the x ever equal to 0? No, because you can't natural log 0. X plus 6 could equal 0. X would equal negative 6. X minus 3 could equal 0. X would equal 3. And then you put these on a number line with a closed circle because this is less than or equal to. You're thinking about what are the signs on this. Now, the e to the x part is always positive. So it's really just looking at when is x squared plus 3x minus 18 positive or negative. That's a parabola like this. And we're looking for the negatives. So any number between negative 6 and 3 should make this quadratic negative. And then when you multiply that by e to the x, it'll still be negative. So my solution set is anything between negative 6 and 3. Including those endpoints because we're looking for where the function is also equal to 0. Now, what about log base 2 of x greater than 0? So sketch this graph. Remember, these graphs are pretty easy to sketch. You've got the point 1, 0 and 2, 1 for this graph. And log graphs, you should have a basic shape in your head. There's a vertical asymptote at 0. Then I plot these points 1, 0 and 2, 1. And it's got this general sketch, right? So if I gave you this graph and said, when is this graph greater than 0, so positive or above the x-axis, hopefully you would look at the graph and say, it's this section right here, right? It's from here on. That's where it's above the x-axis. So what is that point? It's 1. And then any x value to the right of that, out to infinity, will have the graph that's greater than 0. If you wanted to do this algebraically, you would be setting the result greater than 1, because 1 is where a log, when you're logging 1, that's where the expression is equal to 0, and then anything after that would be positive. I think it can be hard to think algebraically, so just graph these. We need to, like I said, you need to be able to graph something like this on the test anyway. Natural log of x plus 5. So the nice points here are 1, 0, and remember it's like E1, but then you're going to go left 5. So instead of the vertical asymptote being at 0, it's at negative 5. So there's this vertical asymptote here. Instead of the point being at 1, 0, if you go left, you're at negative 4. If you go left 5 units, you're at negative 4, 0. And I don't really care about E. It's like up here somewhere. So again, the graph has this shape. I'm not going to give you a crazy complicated log graph for an inequality. Now, when is this graph less than 0? So below the x-axis or negative? Well, that's on this little section here, right? Anything down here. And what are the x values that are on that chunk of the graph? X values between negative 5 and 4. And I'm not including those endpoints because negative 5 is a vertical asymptote. And, negative 4. Negative 4 would be where the graph is equal to 0, and this just says less than. Okay, what about number 18? We're not going to graph this, but we can factor this again. We can factor out an e to the negative x. Now, if you do that, you get 1 from the first term, and then plus x squared minus 2x from the second term. Let's factor that a little bit more. So x squared is x and x. This is really minus 2x plus 1, so it's going to be 1 and 1, minus and minus. So we don't get anything from setting e to the negative x equal to 0. No solution there. But if x minus 1 equals 0, then x equals 1. Think about that graph now. X minus 1 times x minus 1 means that you've got a parabola that just kind of bounces at that one value there, so it's always positive. So this graph is positive everywhere except for 1. So it should be negative infinity to 1 and 1 to infinity. And I wanted the positives this time because greater than 0 is positive. Okay, and then very quick review, evaluating logs. I hope these are easy by now. Remember, evaluate just means find the exponent. Determine the exponent on the base to give you that result. So 5 to what power is 125? 3. Rewrite this if you want to. This is e to what power? The negative 4/5. So the answer is negative 4/5. What's the log of 0.1? That's really saying what's the log of 1/10? Remember, it's a common log, so it's base 10. So what exponent is on 0.1 or what exponent is on 1/10? Negative 1. 4 to the log base 4 cancels out. You're left with the result, which is 17. What power do you have to raise 16 to get 2? It has to be a root, right? It's the fourth root of 16 is equal to 2. So what is the fourth root as a power? It's a power of 1/4. What do you have to raise 1/3 to get 81? It's got to be a negative exponent. It's 3 to the 4th, that's 81. So the answer is negative 4. What is this exponent? The root is always the denominator, and then the exponent is the top. So e to the 2/3 is what we're looking at in there. And log or natural log of 1 is 0 because e to the 0 equals 1. All right, that finishes this worksheet. Hopefully that helps you. If you need more practice with this or if you have questions, please come into office hours or flex time.